Section 6.5, we're going to use properties of trapezoids and kites. So continuing to talk about our quadrilaterals, the next two special types we're going to talk about are trapezoids and kites. First, we're going to go back and review what we know about parallelograms. So this first slide is a parallelogram. I know that in a parallelogram, opposite sides are congruent, opposite angles are congruent, opposite sides are parallel by definition, consecutive angles are supplementary, and the diagonals bisect. Because opposite angles are congruent, the 110 in the top left will be repeated to the bottom right because those are opposite. We can also use that 110-degree angle to find the measures of its consecutive angles. So two consecutive angles, because these are between parallel lines, must be supplementary. So 180 minus 110 gives us the bottom left angle of 70, and the top right angle is opposite, so it's also 70. I know with parallel lines and a diagonal working as a transversal that my alternate interior angles are congruent, so the 75 will come up to this corner. To find the other side of that angle, we have 110-degree angle. This is 75 of it, so if we subtract, we find out the other side is 35 degrees. Again, using the left and right side alternate interior angles makes this 35. On the bottom left, with our 70-degree angle, we know that this part of the angle is 20. 70 minus 20 gives us that the other part is 50. And again, we're going to use alternate interiors to repeat those angles up. Make sure they are alternate, that they go to the other side of the line in that congruent 70-degree angle. We have four angles remaining, the four angles where the diagonals meet. Remember, for a regular parallelogram, these do not meet in any special degree measure. To find the angle that I'm marking in red, we're going to use our 180-degree triangle. So we have 75 and 20, which is 95. 180 minus 95 gives us 85 degrees. Vertical to that is the angle that's on the bottom of those center angles, so that's also 85 degrees. To find this center angle that's on the left, we're going to add up our two angles we know. 35 and 50 is 85. 180 minus 85 is 95. Again, vertical angles, the other side is also 95. That's the things, the properties that we know about any parallelogram. The next review example, we're looking at a rectangle. I have opposite sides congruent, opposite sides parallel, diagonals bisect, opposite angles are congruent, consecutive angles are supplementary. In addition, if we have a rectangle, the diagonals are congruent. So not only do they bisect each other, but each one starts out to be the same measure, which makes all four parts of the diagonals congruent. I also know that I have four right angles. So each one of these angles is 90 degrees. And because in our rectangle, the diagonals are congruent, that makes this an isosceles triangle. So if this angle is 25, the other side of that small bottom triangle is 25. Because this is 25 out of our 90-degree corner, 90 minus 25 leaves us 65. The same thing happens here. We have 65. Again, these are isosceles triangles, so the 65 comes up to the corner, and the 65 comes up to the corner. Out of our 90 degrees, 90 minus 65 leaves us 25 to repeat in these two corners. Let's find one of our middle angles. We're going to do 65 plus 65. We'll get 130, and the 180 triangle minus 130 means this angle in the center is 50. Vertical angles would tell us this one is also 50. A couple different ways we can find this top center angle. I'm going to use my triangle being 180 degrees. So 25 and 25 is 50. 180 minus the 50 leaves me 130, and I can copy that to the vertical. We can also use the fact that the 50 and the 130 are a linear pair. They have to add up to 180. So in addition to what we know about a parallelogram, a rectangle has all of those properties. Because it's a parallelogram, it also has four right angles, diagonals are congruent, and it forms isosceles triangles. Let's move on to a rhombus. A rhombus is also a specific type of parallelogram. This one has all four sides congruent. So not only are opposite sides congruent, but all four sides are congruent. We still have our properties of parallelograms. Opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, they add up to 180, diagonals bisect each other. In addition, if it's a rhombus, the diagonals are perpendicular, and the diagonals bisect the angles at the vertex. So if I only have the 140, that's okay because the rhombus bisects the angle. That means each side of this is 70. Opposite angles are congruent. This one is also 140, and both halves will be 70. We still know that consecutive angles are supplementary. They add up to 180 because this is a parallelogram. So if this is 140, 180 minus 140 tells us this top right angle is 40 degrees. Opposite angles are congruent, so the bottom left is also 40. This diagonal is also bisecting the angle, so each half of this is 20. Same thing on the other 40 degrees, each half is 20. I know in a rhombus that all my center angles should be 90, but we'll double check. 20 plus 70 is 90, plus this 90 does give us 180 in a triangle. So things we know about a rhombus, all of our properties of a parallelogram, diagonals are perpendicular, and the diagonals bisect the angles at a vertex. The last one is a square. You will usually be given a square, not marked. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. Any two consecutive angles are supplementary, they add up to 180. In addition, a square is not only a parallelogram, it's also a rectangle because it has four right angles. So the properties I get from a rectangle is that the diagonals are congruent. There are four right angles. And these form isosceles triangles. This is also a type of rhombus because all four sides are the same. So the properties it gets from a rhombus is that the diagonals are perpendicular, and these diagonals bisect the angles at the vertex. So each part of this is 45, and this will form 4 45, 45, 90 right triangles. So if we look at one of these, there's a 45, 45, and here's the 90. And we'll talk more about those special right triangles. You will need to know from a blank square with the diagonals drawn how to fill in all of the angle measures. The two figures we're going to focus on for today is a trapezoid and a kite. A trapezoid is a quadrilateral. It has four sides, but it only has one set of opposite sides parallel. So we've talked about our parallelograms, that a rhombus, a rectangle, and a square are all types of parallelograms. Those are separate from the trapezoid. This is not a parallelogram because only one set of opposite sides are parallel. The opposite sides are called a base. So we have the bases AB, and it's the opposite sides that are parallel. The other two sides are called legs. So bases were AB and CD. The legs would be AD and BC. Because we have one pair of opposite sides parallel, we still know some things about the angles, but be careful with this one because on one side, these two angles between the parallel lines must add up to 180. And then on the other side, those two angles between the parallel lines must add up to 180. Otherwise, I know that the sum of our quadrilateral is 360. So the angles in the trapezoid add up to 360. We're also going to draw on some medians. Our median is kind of like the mid-segment of a triangle. Is a segment that joins the midpoints of the two legs. Therefore, the median of a trapezoid is parallel to the bases, and its length is half the sum of the lengths of the two bases. Okay, so let's see what that looks like. So it's parallel to both sides. So all three segments are parallel. And to find the length of the median, and we're going to use a little m for that, we have the first base plus the second base divided by 2. Now you want to be careful in your calculator. Let's say the first base was 3 and the second base was 2 and you wish to divide it by 2. make sure in your calculator that you either put parentheses around this or that you add, hit enter, and then divide by 2. If you type it in like this, you will not get the right answer. Your calculator will do 2 divided by 2 and then add the 3. We want it to do 3 plus 2 is 5, divided by 2 is 2.5. So make sure if you're putting the formula for a median in your calculator that you either use parentheses or once you do the sum, you do the adding, hit enter, and then divide by 2. So we're going to use this to solve some problems. Example 1, BC, and remember if we don't have the segment symbol above it, this is the length of BC equals 9, the length of AD is 21, and I'm looking for the length of EF. To find the length of the median, we're going to add the bases and divide by 2. Remember, if you want to put this into your calculator, 9 plus 21, enter, is 30, then divided by 2 will give us 15. It's an average of the two bases. Example 2, the length of segment AD is 12, the length of segment BC is 7, and we're finding EF. Same formula, we're going to do 7 plus 12 divided by 2. 7 plus 12 is 19, divided by 2 gives us 9.5. Example 3, and I want to stress that these pictures are just drawn for reference so you know who the bases are and who the median is. This one says that BC is 7 and AD is 1. And that doesn't look like what those links should be, but this picture is just a picture we're using for all the problems as a reference so you can see where the sides are. To find EF, I'm going to add the bases and divide by 2. So 8 divided by 2 is 4. Now, as we work through these problems, we're going to change what you do and don't know and what it is that you're looking for. So for this problem, we have the length of BC is 9, the length of EF is 13, and I do not know the length of AD, so I'm going to call that X. So if I plug into my formula, if I add the sum of the bases, so 9 plus X divided by 2 equals 13. So we're going to solve this. I'm going to start by multiplying both sides by 2. So 9 plus X equals 26. And if we subtract 9, we find that X is 17, because 17 plus 9 is 26, divided by 2 is 13. So the length of AD is 17. You're plugging in the parts you know and then solving the equation. Let's try another one. Example 5 says the length of AD is 27, the length of EF is 16, and I do not know the length of BC. So instead of using an X, you could also just use BC, the letters, so that when you solve, you know what you found. So the length of BC plus 27, the length of the other base, divided by 2, gives you 16, the length of the median. To undo the divided by 2, it's kind of like when we did midpoint backwards in the first half of geometry. We multiply both sides by 2, so BC plus 27 equals 32. We subtract 27 from both sides, and the length of BC is 5, because 27 plus 5 is 32, divided by 2 gives us the length of the median, 16. Go ahead and write down and try number 6, and we'll check this when you come into class. So try this one for class, and we'll check it when you come in. Pause if you need to. Moving on to number 7, the length of AD is 3x plus 5, the length of BC is x plus 3, and the length of EF is x plus 7. We're going to use the same formula, base 1 plus base 2 divided by 2 gives us the length of the median. So if I do x plus 3 plus 3x plus 5 divided by 2, that should equal x plus 7. Now I could do the like terms on top, or I could get rid of my fraction. It is up to you. So I'm going to go ahead and add my like terms. We have 4x plus 8 divided by 2 equals x plus 7. Now you have two options here, and I want to talk about both, If the numbers are even, you could divide by 2, but both parts needed to be divided by 2. So if you do the divide by 2, on the left side you'll have 2x plus 4 equals the x plus 7. You could also multiply by 2 like we have been, but if you do that, you need to distribute that 2 through the right side. So 4x plus 8 equals 2x plus 14. I apologize for that happening in the video. If we subtract 2x and subtract the 8, hopefully the screen is back, we have 2x equals 6, and when we divide, x is 3. Now they are asking us to plug in and find the length of EF. So we're going to take the fact that x is 3 and we're going to plug that back in. So 3 plus 7 gives us the length of EF is 10. You could plug the 3 back into the other parts and check. 3 plus 3 gives us that the length of BC is 6. And at the bottom we get that AD is 14. 6 plus 14 is 20, divided by 2 does give us 10. Okay, the next example, we're going to look at our trapezoid and the angles with the median drawn in. Now, in our trapezoid, I know that one pair of opposite sides, the bases, are parallel, and that the two angles that are consecutive between those parallel sides must be supplementary. So if this bottom angle A is 80, then the top angle B is 100. If the bottom angle D is 60, the top angle C must be 120, because C and D are the ones that add up to 180. Now in between, since our median is parallel to these two, this works like another pair of parallel lines with our transversal, and again we're going to have those same side or consecutive interior angles. So E and A must also add up to 180, or you can know that B and this angle FEA are corresponding angles, and they're both 100 degrees. The same thing with A and angle FEB. Those are corresponding angles, like that one and that one, and that's 80 will copy up. Same thing happens over here. C is going to be the same as angle EFD, so the 120 comes down. D is going to be the same as angle EFC, so the 60 comes up. If you check the four corners of our large trapezoid, they should add up to 360. So 100 plus 120 plus 60 plus 80 does give us 360. You could also check this small top trapezoid formed by the median, or the small bottom trapezoid formed by the median, and the four vertices are going to add up to 360. Remember that all quadrilaterals sum to 360. As we talk about trapezoids, we also have a special kind called an isosceles trapezoid. This is a trapezoid with congruent legs. So in this kind of trapezoid, the legs are congruent. Because of this, the base angles are congruent and the diagonals are congruent. So you need to know that if it's an isosceles trapezoid with the two legs congruent, it also has base angles that are congruent, the ones that are on the same side against the same parallel line, and that the diagonals are going to be congruent. So in our isosceles trapezoid, we're going to fill in the missing angles. Because this is isosceles, the legs are congruent. I have base angles that are congruent, so against the same parallel line, this 60 will repeat over. Now, knowing that between my parallel lines I have supplementary angles, I know that the 60 and the angle that's up against the other parallel line must sum to 180. So this angle will be 120. These are again our base angles, so they're going to be congruent and they're 120. If you add those up, you'll find that all four angles in our quadrilateral do sum to 360. So this legs are congruent, these base angles, the 60s are the same, and these base angles, the 120s, are the same. I also know that the diagonals are congruent, and we'll use that. In this isosceles trapezoid, so it's isosceles, I know the legs are the same, we're going to fill in the missing angles. If this top left angle is 70, I know that that's congruent to the top right angle at 70. The same thing happens with the 110. These are base angles, they are congruent. Looking at our bottom right angle, if this is 110 and this part of it is 38, we're going to do 110 minus 38, and we'll get 72. Now I know that the top and the bottom are parallel sides, so this diagonal that's drawn in works like a transversal. So the 38 is an alternate interior to this angle of the 70, so we're going to copy that down. I cannot copy the other side. It's only the ones that are alternate interior where the parallel line meets the transversal and where this parallel line meets the transversal. Kind of like what we did when we did triangle proofs. To find the other side of the 38 on the top left, we're going to do 70 minus 38, and we find that that's 32 degrees. And those are all the missing angles. The other diagonal will not be drawn in. Following that same process, this isosceles trapezoid has congruent legs. Base angles are congruent, so I can copy the 45 and the 135. 20 of the 45 is used, so the other side is 25. Where the parallel line meets the transversal is an alternate interior with where the parallel line at the bottom meets the transversal. So the 20 comes down. 135 minus 20 gives us 115. The last kind of quadrilateral we're going to work with is a kite. A kite is a quadrilateral with two pairs of consecutive sides that are congruent. And we're going to talk about our properties of a kite. This will have two pairs of consecutive sides congruent, so two sides in a row will be the same. The diagonals are perpendicular to each other. They will cross at 90 degrees. And one pair of opposite angles are congruent. And so we'll talk about which pair we know are congruent. So I'm just going to draw one sketch. We will do some examples with the kite when you come to class. Kind of looks like a typical kite that you picture. Consecutive sides are congruent. The diagonals that are drawn in are perpendicular. They cross at right angles. And you have one pair of opposite angles that are congruent. This entire angle is the same as this entire angle. So when you come to class, we'll be working on page 359 to 363, 10 through 24, 31 to 33,